This question is asking how many of these molecules are polar. To figure that out, we first need to draw the Lewis structures, figure out the bond dipoles, and then partial charges of each atom in the molecule. After that, we should figure out the net molecular dipole to then figure out which of these molecules are polar. So the first step would be drawing a Lewis structure. So to figure that out, we need to know how many valence electrons are in the molecule. Sulfur has 6, as well as oxygen, but there are 3 oxygen atoms, so in total there are 24 valence electrons. You start by drawing each atom, and then connecting the atoms with a line or a bond that represents 2 electrons. Okay, and then you start by filling out the outer atoms first, using the 24 valence electrons that we have. So because we do not have enough valence electrons to fill this shell up with 8 electrons and this one, we're going to draw a double bond here so that all the molecules are satisfied. So all the atoms are satisfied. So now we have to figure out the partial charges of each atom. To figure that out, we need to look at which atom is more electronegative. So on the periodic table, electronegativity goes from left to right and up. Therefore, fluorine is the most electronegative atom. So in this case, oxygen is more electronegative than sulfur. Therefore, the oxygens have a partial negative charge. That is symbolized here with a delta negative. So because all of these atoms are partially negative, sulfur will be partially positive. Therefore, the bond dipoles go from sulfur with the arrow pointing to oxygen and a little plus right there. As I said earlier, fluorine is the most electronegative atom, so it will have a partial negative charge, and oxygen will have a partial positive charge, the bond dipoles going as such. So for this one, I just want to point out that beryllium does not have a full octet. This is because it is an octet violator and does not require 8 electrons. Beryllium is less electronegative than chlorine, so chlorines will have the electronegative charge. Beryllium will have the partial positive charge. In this molecule, carbon is less electronegative than chlorine, so it will have a partial positive charge with all the chlorines having a partial negative charge. So the bond dipoles, again, will be pointing towards the more electronegative atom. Okay, and then ozone is a special case because all of the atoms are the same, therefore there are no there are no bond dipoles at all. Okay. So the next step would be to figure out the net molecular dipole. So we're going to look at the molecular structure of each molecule. So S has 3 domains. Domains are the region surrounding the central atom that contain electrons. So this one has 3 domains and therefore is trigonal planar, and because they are all identical, the bond dipoles cancel and there is no net dipole. Therefore, this atom is nonpolar. So when we look at this molecule, there are 4 domains. But because each domain is not identical, see the 2 non-bonding pairs and the 2 with a single bond to fluorine, there will be a net dipole. So in actuality, the molecule looks something like this. We have our fluorines, and then our 2 non-bonding pairs. This is the molecular geometry of that atom. The 2 non-bonding pairs make the bond dipoles go like this. So there is a net dipole, and this molecule is indeed polar. So for this one, beryllium has 2 domains. because these domains are both identical, its molecular geometry is linear, there will be no net dipole because they cancel, this molecule is non-polar. This molecule up at the top has 4 identical domains. Because they are identical, the bond dipoles cancel, this molecule is non-polar. So this one does not have any dipoles to begin with, and even if it did, both domains are identical, this molecule is non-polar. So back to our original question, how many of these molecules are polar? Only one. This was the only one that was polar. Okay, thank you.